Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel. Today's topic of discussion is the DC voltmeter. Our objective is to introduce the DC voltmeter function on the digital multimeter. This lecture operates under the presumption that the viewers watch the ohm meter and proto-boards lectures, both available at the Big Bad Tech channel. If you haven't watched these lectures yet, or only dimly recall their contents, please take the time to do so now. For the purposes of today's lecture, we'll be making use of the Fluke 87 digital multimeter. This in no way is meant to be neither an exhaustive review of this tool, nor an endorsement of this particular manufacturer or model. I only wish to present the function of interest on a representative example so the viewer can gain some practical exposure to this function and interpret the manner in which results are displayed. A digital multimeter, or DMM, is a single meter that has multiple, hence the term multi-mode settings. DMMs can be used to measure both DC and AC voltage and current, resistance, capacitance, forward bias voltage of a diode, frequency, and much more. Today, we're only going to look at the DC voltmeter function on the digital multimeter, where a DC voltmeter is a device used to measure the DC voltage rise induced by a DC source, and/or the DC voltage drop across the two terminals of a load element inside a circuit. We'll examine other functions of the DMM in later lectures. This discussion of DC voltmeters will be brief for two reasons. One, using a voltmeter really isn't that hard, and two, the topics of voltmeters, power supplies, ammeters, and electrical circuits are tightly intertwined, and it's hard to separate one without going into detail about the other. This being said, I'm going to rip them apart and send them to opposite corners of the lab where we can get a good look at one of them without being entangled with the others. This is the briefest of brief summaries of voltmeters and serves only as a springboard for later discussions. Stay tuned for later lectures which will include further applications of DC voltmeters. If you recall, voltage is an important basic electrical property. Voltage is a measurement of how much energy possessed by a group of charges, where 1 volt is 1 joule of energy per coulomb of charge. Voltage is a two-point measurement. Current, in contrast, is a measurement of moving charges through a single point, where 1 amp of current is 1 coulomb of charge per second. This implies that voltage and current are not the same thing, and they are not measured in the same manner, nor are they measured with the same equipment. At a basic level, voltage is a differential observed between 2 points. Voltage is measured across something, where one point is measured with reference to another. The phrase "with reference to" means that here is the point I'm comparing all other points to. Customarily, the reference point used by voltmeters is the black common lead. The red lead then measures the voltage differential at some point of interest with reference to the black lead. Let's use this circuit for the first half of this lecture to demonstrate the use of the voltmeter. Consider a 5-volt source supplying current to a 200 ohm resistor. An application of Ohm's law demonstrates this resistor would draw 25 milliamperes of current. Application of the power formula demonstrates this resistor would dissipate 125 milliwatts of power. Given the direction of conventional current travel, we should expect a 5-volt drop to be exhibited across the resistor, oriented positive to negative, top to bottom. To measure the voltage rise induced by the source, one would place a DC voltmeter common lead on the negative terminal of the voltage source and the red lead on the positive terminal of the voltage source. A voltmeter configured in the following fashion would measure a 5-volt rise. To measure the voltage drop across an element in a circuit, one would place the voltmeter common lead on the assumed negative terminal of the element and the red lead on the positive terminal of the element. A voltmeter configured in the following fashion would measure a 5-volt drop. In both scenarios, the voltmeter is side by side or in parallel with the element of interest, measuring the voltage differential between 2 points. An ideal voltmeter acts like an infinite resistance through which no current will flow, and the presence of which will not influence the circuit in any way, shape, or form. In reality, a real-world voltmeter does not have an infinite resistance, but rather an extremely high resistance, and will subtly influence the circuit under inspection. For now, let's simply assume an ideal scenario in which the voltmeter acts like an infinite resistance through which no current will flow and does not affect the circuit. We'll examine instrument loading effects in later lectures on series parallel circuits. Let's use the DMM in DC voltmeter mode to measure voltage in a real-world circuit. To do so, we need to use the checklist. I'm not urging you to use this checklist every time. I'm demanding you use this checklist every time. This checklist will save your measurement equipment and circuit a lot of costly downtime and may potentially save your life. I am not overstating the benefits of using this checklist. Use the checklist. Think about it. Really think about it. Take your time and think before you act. The checklist is 4 steps. follow them 1 through 4 and you will get it right every single time. Skip a step, do a step wrong, or do a step out of order, and you will get it wrong every single time. Function, leads, range, placement. Function. We need to place the DMM in DC voltmeter mode. Place the Fluke 87 DMM in DC voltmeter mode by turning the selector switch to the position identified with a capital V with a straight line above it. This is in contrast to the V with a squiggly line over it, which is utilized for AC voltage measurement. Leads. Before we make use of the DC voltmeter function, we need to insert the leads in the right place. Black lead into the black common hole. Red lead into the red hole indicated with a V, the shorthand for units of voltage over it. Yes, you can put a black lead in a red hole or a red lead in a black hole, just like you can put a hat on your foot, but that is not its intended purpose. Range. Don't worry about it. The Fluke 87 is auto-ranging, meaning it automatically picks an appropriate range to obtain the most precise results. Note you can force it out of auto-range mode into manual range if you want to, but we'll keep it as is. Finally, placement. All you need to do to check the voltage differential between 2 points is to place the 2 test leads on the 2 points of interest. Here's a triple output benchtop power supply. 2 outputs are adjustable, and a third establishes a fixed 5 volt differential between these 2 binding posts. We'll examine this power supply in greater detail in later lectures. To measure the 5 volt output, the black common lead of the voltmeter is placed in the black negative terminal of the source, and the red test lead on the red positive terminal of the source. When the power supply is turned on, the voltmeter displays a value reasonably close to the nominal or nameplate value of the 5 volt power supply. This is sometimes known as the unloaded voltage or the open circuit voltage, meaning it is the voltage differential established by the source when it is not providing current to any load elements in a circuit. If one was to swap the lead placement such that the black common lead is on the positive terminal and the red lead is on the negative terminal, the DC voltmeter displays roughly negative 5 volts, meaning a 5 volt differential still exists, only that the negative terminal is 5 volts lower than the assumed reference.